So in our last video, we learned how to make a binomial PDF in a table format for our candy corn data. We're looking at the proportion of people from our survey who guessed within 100 candy corns of the real number, and then using that idea to talk about what happens if we were to continue doing other surveys of people, asking them to guess how many candy corns are in that jar. So as a reminder, the purpose of this video is we're going to use our PDF to calculate the expected value of our data set. The expected value of our experiment that we're conducting, where we have 20 trials with, we're talking about asking 20 people. So this video is going to be talking about finding the expected value or the mean of our PDF using our table. And then our next video will be talking about how to find the standard deviation of a PDF using that table, all in Excel. I do want to point out that we can actually calculate this expected value in different ways for our PDF because of something in particular that I'll get to. But we are going to go through this process. This is our Canvas page where I wrote out a lot of information about expected value and how to calculate it, specifically from a table where we have the one that's very similar that we're using in our Excel sheet, where we have X values, so different random variable values that random variable can take on, and then the corresponding probability of each of those values. So how we calculate the expected value is we take each X value, each random variable possible value that it can take on, and multiply it by its corresponding probability. And then we add all of these up. So this is how we've been learning it so far. And this is the formula, if you remember seeing this, mu, which is what we call the population mean or expected value. Mu is equal to the sum of, so we are adding together a lot of products. And these products are each X value multiplied with the probability that it corresponds to. So when you do that, for this example, we got 3.75. So what we're going to be talking about here, notice here I put foreshadowing, we can actually calculate this value in Excel with just like one enter will calculate this for us. So that's the purpose of this video, is to show us how to do that. So in Excel, if we want to find the expected value, which we often label as E of X, so expected value of the random variable. Again, this is what we would expect to happen if we were to continue this experiment where we're asking 20 people to guess how many candy corns are in this jar. And remember, our random variable is measuring or counting the number of people who guess within 100 of the real value. And the real value, if you remember, was 343. Okay, so here's how we do this in Excel. It's amazing. All right, so if you remember that formula I just mentioned, we were taking the sum of a bunch of products. And so we could sit here and make this table in Excel and then add them all together, but we can do this much more quickly. So if you type equals, again, this tells Excel we are starting a formula or a function or something like this. If you start typing in sum, we've actually seen this function before, sum product. So if you remember, this will give you the sum of a bunch of products. So if we double click here, now remember it asks for array 1 and array 2. So what we're looking for is we're multiplying each of these X values with its corresponding probability. So what this function does really well is if you click and highlight all of these, so again, you're holding down your mouse as you're doing this. So you're clicking on the X column, the numbers, not the title. So you don't want to grab this function, this box right here, because it's not one of the actual values you're wanting to multiply. That's like the title. Okay, so now we've highlighted this column, which is what they're calling an array. If we put a comma and then highlight the corresponding array or column for the probabilities and then release, what this is telling this function to do is essentially multiply each of these rows with one another. So take 0 times 0.0009 and then add 1 times 0.0076. plus 2 times 0.0303. So this is going to do this so fast. Okay, are we ready? Ta-da! This is our expected value for this experiment, meaning and if you remember in the previous video, we saw that the highest probabilities are here with 5 and 6. So this agrees with our, I'll say our anticipation that more likely than not, if we are asking 20 people to guess this number, usually about 5 or 6, closer to 6 people, would guess within 100. So going along with this, this doesn't mean though for one sample we're going to have 5.91 people guessing. What this means is if we did this repeatedly, the average number of people would eventually come out to 5.91 if we did this forever and ever and ever and ever. If you remember too, because we have a binomial experiment, we actually know that this expected value is also the number of trials times the probability of success. So if we actually type this in here, we should get the exact same value. So again, this is a binomial experiment. We can calculate this in a different way, but to calculate our expected value from a PDF that's in a table, I wanted to show you this function as well. So that's it for this video. In the next one, we will look at standard deviation. See you there.